In this video, we're going to look at a way that we can multiply two vectors together using something called the dot product, or you'll sometimes see this referred to as the scalar product. So basically, if we have two vectors, v and w, and we want to multiply them together, then we multiply them component by component. So we'll multiply the I component by the I component, multiply the j component by the j component, and then just add them up. Now notice that our final answer is not a vector. Our final answer is a scalar. It doesn't have any i's and j's in it any longer. So we're just taking the scalar part of the component, not worrying about the i's and j's, just taking the a's and the b's. Okay, so let's go ahead and let's multiply a couple of vectors together using this dot product. Okay, so we have two vectors, v and w. V is 3i minus 4j, and w is 2i plus 6j. We're going to use our dot product to multiply these together. All right, so first we're finding v dot w. So we're going to multiply the I component of v times the I component of w plus the j component of v times the j component of w. So 3 times 2 plus negative 4 times 6. And then just do the math. So we would have 6 minus 24, which would be a negative 18. And that's our final answer. Okay. All right, let's say we want to find w dot w. So the I component of w times the I component of w plus the j component of w times the j component of w. So if we simplify this, we would have 4 plus 36, or 40. All right, w dot v. So we're going to take the I component of w times the I component of v plus the j component of w times the j component of v. So this would be 6 minus 24, which would be a negative 18. Okay. Something that I want to point out to you guys here is notice that our answers for A and C are exactly the same. So V dot W is always going to be the same as W dot V. Dot product, the order does not matter. Just like regular multiplication, if you switch it around, you're going to get the same answer. Okay, and then V dot V, we're going to multiply the I component of V times the I component of V plus the j component of v times the j component of v. So that would be 9 plus 16, or 25. Okay. All right, so this is basically all there is to the dot product. Okay. So the next thing we're going to do with our dot product is use it to find the angle between two vectors. Okay. So say we have two vectors, v and w, both starting from the same point. Okay, so say that's our V, that's our W, and they're both coming from the same point. Okay, then if we want to find the angle theta that falls between these two vectors, then, oops, I just realized that there's a typo in my formula here. I'll fix that in the notes before I post them up online. So if we want to find the angle between our vectors, we use this formula. So we'll have the cosine of theta is equal to v dot w divided by the magnitude of v times the magnitude of w. Okay, so using this formula, we're going to be able to find that angle theta between our two vectors. Okay, so let's go ahead and take a look at an example. So we are trying to find the angle between the vectors v equals 2i plus 5j and w equals 4i minus 3j. So the first thing that we want to do if we're looking for this angle, if we're thinking of using this formula right here, is to find the dot product. So we're going to start by finding v dot w. So same as we were doing above. So the I component of V times the I component of W plus the J component of V times the J component of W. All right, so this would be 8 minus 15, which would be negative 7 as our dot product. Okay. All right, then we want to find the magnitude of each of our two vectors for our denominator. So magnitude of a vector, remember, is just using Pythagorean theorem. So the magnitude of V would be the square root of 2 squared plus 5 squared. So that's going to be the square root of 29. And then the magnitude of W is going to be the square root of 4 squared plus 3 squared. And that would just be 5. Okay? Okay, so once you have all the pieces, then you can just put them together in your formula. So we're going to have cosine of theta is equal to negative 7 divided by the quantity square root of 29 times 5. Okay. All right, now this is definitely not an angle on our unit circle, so we're going to want to pull out our calculators. So theta will be the inverse cosine of negative 7 over 5 squared of 29. Now, if you want to, you can try and simplify this fraction. You can rationalize your denominator, but since we're just plugging it into the calculator anyway, I'm not going to bother. I'm just going to leave it unrationalized. So if we plug this in, we would get the angle 105.07 degrees as our final answer. So that is going to be the angle between our two vectors. Okay. I'm going to leave example 3 for you guys to try on your own. Okay, so sort of an extension of this then is we can use this to determine if vectors are parallel to each other or perpendicular to each other. Okay, see right here I said parallel or orthogonal. Okay, orthogonal is just another word for perpendicular. Okay, so let's consider the first case where we have two vectors that are parallel to one another. So if our vectors are parallel, then that can happen one of two ways. Either they're pointing in the exact same direction. So this is our V and this is our W, and they're pointing in the same direction, meaning the angle between them is 0 degrees. Or they're pointing in exact opposite directions, meaning the angle between them is 180 degrees. Okay, so in either case, if the angle between our two vectors is 0 degrees or 180 degrees, then we can conclude that those two vectors are parallel to one another. Right, now, if we want two vectors to be perpendicular to one another or orthogonal to one another, then we need a 90-degree angle between our two vectors. So if we have a 90-degree angle between our vectors, then they are going to be perpendicular. Okay. Now, one thing interesting here is that this will only happen if the dot product of our vectors is equal to 0. Okay, so if the dot product comes out to 0, then the two vectors are always going to be perpendicular to one another. Okay. All right, so let's go ahead and let's take a look at a couple examples. So we want to determine if the vectors are parallel, perpendicular, or neither. So in order to do this, we're going to use that same formula that we were using before. This guy right here, cosine of theta is equal to V dot W divided by the magnitude of V times the magnitude of W. So we're going to start by finding the dot product. Okay, so V dot W, multiply the I component of V times the I component of W plus the J component of V times the J component of W. So we would have 6 minus 40, which would be a negative 34 as our dot product. Okay. All right, the magnitude of V is just Pythagorean's theorem. So square root of 3 squared plus 5 squared. going to be the square root of 34. And then the magnitude of w, square root of 2 squared plus negative 8 squared. That's going to be the square root of 68. Okay. All right, so then putting that all together into our formula, we'll have the cosine of theta is equal to negative 34 divided by the square root of 34 times the square root of 68. Okay. Again, if you want to simplify this, you certainly can, but you absolutely don't have to if you're just going to plug it into your calculator anyway. All right, so if we go ahead and plug this in, we'd be looking at the inverse cosine of negative 34 divided by the square root of 2312. Okay, and then that is going to give us 135 degrees. Okay, so 135 degrees, that is neither parallel nor perpendicular, so our answer is neither. Okay. All right, let's look at B. So again, determining if these are parallel, perpendicular, or neither. So start by finding the dot product, V dot W. So we would have 2 times negative 1 plus 1 times 2. Right, and that's going to come out to, oh, sorry. So that is going to come out to 0. Okay, so our dot product is equal to 0. Now, if you think about your formula, we know that cosine of theta is equal to V dot W, so dot product in the numerator, divided by the magnitude of V times the magnitude of W. But if we have a 0 in the numerator, then it doesn't matter what's in the denominator. This is just going to come out to 0. This is saying cosine of theta is equal to 0. Okay. Well, if we think about our unit circle, cosine of theta is equal to 0, then that is going to have to be a 90-degree angle, which means our vectors are orthogonal or perpendicular if you prefer. Okay. All right, guys, I am going to leave part C for you to try on your own. Okay, so that is it for our dot product.